Okay. What I'm going to do for this question is a new practice, actually. First of all, I'm just gonna get used to writing like class solution, and so create a class called solution. Create a method for that class called maxDept with parameter root of type root, and I'll just do like optional tree node. Yeah, sure. Optional tree node. And this method also returns an integer. Okay. Now I'm gonna get rid of that class. I've seen it already, so it's kind of cheating, but now I'm gonna write it out. And the reason why I'm doing this is because I actually had an interesting experience with a mock interviewer, and they, none of this information was given to me. Like elite code, we take it for granted that the class and everything is given to us, but in this question that they did, it wasn't given, and it was even said that like he basically the advice that he gave me was expect the worst. So expect like you're given nothing. And I'm like, that's such an interesting point to make, because that really threw me off, to be honest. Like the fact that it's a very simple thing, but when you're out of practice, it can really stump you. So I create a method called maxDept. So we can do this maxDept. And parameter root. Okay. And it should be an optional tree node. I noticed lists are like this as well. You write linked list and an int inside, and a tree node, we have the definition here. And you want to return an integer, so you can do that. And you can just, yeah, I think like that should be okay. Let's see if there's any syntax errors. Run. Takes one, but two are given. Okay, so the other thing I missed was this self. It seems like a common pattern in Python. I forget why this is actually done, but I forget why it's actually done. I should probably search that up. But yeah, cool. If I do this, indentation. If I do this, run. Okay, indentation, still there. How was it written before? If I restart this. Yeah, that's okay, and then yeah, indentation like before. Alright, so for any notes whatsoever, another trick I learned is I do this like comment thing, right? Like comment. Like why? Why do you do that to yourself? Like I did that in my mock interviewer, and I'm sure I'm not sure if you noticed or not, probably did. But why do that when you can just do like this and just write whatever you want? Oh my god, look at this speed. Oh, beautiful. I'm definitely not answering the question. Well, I should be. I should probably start the timer as well. Sorry, just give me 1 second. Hold on. Alrighty. Timer. And yeah, alright. So I'm gonna give myself some good time to do this because it's my first time like really like even the test cases here, like you shouldn't take that for granted either. Like apparently Roblox, which is a company, they apparently require you to write your own test cases. And apparently they do that for your online assessment too. I thought that was just like the technical interview, but apparently for your online assessment you gotta write your own unit, like your test cases. Like I'm not sure if it's like they only give you like provide you with some test cases and then you have to like fill in the rest, or like how that works. But that like seriously like I'm like whoa, that's scary. Like I did not practice for that. So I'm gonna try practicing for that too. First thing first, I practiced with class definition. Let's read the question. Okay, let's get to it. Maximum depth of binary tree. Easy problem. Wanted to get myself used to trees again. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root down to the farthest leaf node. And yeah, like 327, like 3 is the answer here. So first thing first, let's make our own example. Okay, so we know a binary tree. What is a binary tree? A tree with 2 nodes. Does it have to have 2 nodes? I'm looking out. I know there's like balanced binary tree. Almost completed binary. Like there's different types. Or does it have to be a tree with up to 2 nodes? Hold on, I'm being summoned. Give me 1 minute again. Okay, I'm back. Yeah, this is a good thing to confirm. I'm gonna assume it is up to 2 nodes, but hopefully an interviewer would correct me if I'm wrong. Well, actually, it's probably like basic knowledge. Whatever. Okay. And how do you write these list? So 3, 9, 20, 0, 15, 17. All right. So actually, I'm writing this example up, but should I ask clarifying questions first? Like, sometimes we're not given all the information. Given the root, so can this root be none? Like, does it have like what's the max? Like the minimum? It can be a maximum. And what about the values inside the node? I don't think that's really relevant to this problem though. But yeah, it's not really relevant to the problem. So if you have 9, 10, 12, 15, 16, 4, 1. Okay. If I take this, just put it here. This is like HackerRank's whiteboard. Apparently, I don't know, it's really useful for me. Look how smooth that is. I was using Miro before if you watch my past videos. And this is so much smoother. I'll be using this for this upcoming interview, so I just want to get practice with it. So 9, and then 10, 12, right? And then 15 here, 16 here, 4 here, 1 here, like similar to what was given to us in LeetCode. Different than a binary search tree, which I think is ordered. This one doesn't seem ordered to me. I'm trying to think, like, if I had more trees than this, is it really gonna help? Not really, so I'll leave it at this. This is a good example. Okay, and what is the length of this? Like, what's the output? We know the output is 3 because 1, 2. Hold on. Is it 3 or is it 1, 2? Hold on. Let me read the definition. Maximum depth is the number of nodes along the longest path from the root node down to the farthest left node. Yeah, okay. So 1, 2, 3. Yeah, 3. It's not the edges, it's the actual nodes. So 3. Which is kind of the same example as before, so I didn't really learn much from that example. I asked clarifying questions, so let's check constraints. Number of nodes in the tree. It can be 0. Okay, good to know. Power 4 and the values, again, not really relevant for this question. All right, so I come here and I'm like thinking, I'm also thinking, what's the expected time complexity or space complexity you're looking for as an interviewer? Yeah, I don't know about that too. I also didn't read this. Let's read it. Definition for a binary tree node. We have self value, default value 0, left node, left subtree, default value none, right subtree, default value none. Just sets it up. Cool. All right. Well, the maximum depth of binary tree. Would you have to go through all the nodes? So that's like, because I would like, I'm using this picture as a reference. Maybe I'll use my own picture. Let me zoom out. And cool. Yeah, like to determine the longest path, I would have to go down this path, down this path, down this path, down this path, and at least like the naive implementation, like the first, well, actually, hold on. Before even like going into the code, how would I do this as a human? That's the first thing that you should do. That I hope to do. Now, as a human, I'm looking and I know that the longest path is the I have to start from the top node and go all the way down to like its leaf. So I go down 1, 2, 3. I'm like, okay, so that's good. 1, 2, 3. Okay. 1, 2, 3. Okay. 1, 2, 3. Okay. 3 is the longest. Like it's the biggest depth I see, and so the answer is going to be 3. In this case, I intuitively like basically when you see. Maybe this is a good thing that was shown. When you see something like this, you just intuitively know, like I see in this graph that this path is longer. And it's because I see that this this kind of node right here, this node right here it does have children. Whereas this one doesn't. Like I just see that visually. That's like an optimization. Like instead of just having to check this path towards 10, I know I really should be going down this way. So I've kind of talked about, like I've addressed like kind of the naive implementation, right? As a human, I just go down every single path, which is O of n, because the n being the number of nodes. And then the bit of a optimized solution is like, well, as a human, I visually just see that this path is longer, and it's just because I see it's longer. How does the code see it's longer? Well, it goes down and checks each of the path. Can I get this better than no event? Let's see. Are there any like hints or anything? I don't know. Alright, so it's been 10 minutes. I should learn how to pace myself in these interviews. So I've talked about like a naive implementation. What else? So I'm currently like brainstorming an optimal solution. Though at this point, you'd also want to ask like, hey, like this is my naive implementation, right? At O of n. Time complexity, space complexity is O of 1, I think. Yeah, O of 1. I don't see an opportunity to. Yeah, I don't see any like space like additions in this. Like, what I mean is like I don't see any like any more space being used other than like constant time space. Or constant space complexity. Maybe I should have said it that way. And at that point, I'd be like, hey, do you want me to optimize from O of n? Or do you want me to just implement the brute force kind of solution and go from there? For my mock interview, they said they wanted me to optimize it. Is there an optimization? I don't know. So I'm gonna go the unoptimal way and see what the code produces. I'm also, can I write my own test cases in here? I don't know. Okay, well, let's see. So max depth, like depth equal to return depth. Maybe I'll do like maximum depth. It's hard when like the method itself is the same name. Okay, if root, this is like a base case of sorts. We just, well, actually, this is already considered over here. So we don't actually need this base case, I think. We don't need this. Maximum depth. If this is crossed, if root is not none, then we know we can increment it by 1. If root to the left is not none, then we call max depth over the left. Okay. Maximum depth plus equals. If root not right is not run, then maximum depth, I'm a max depth onto the right subtree is not none. I don't know if this makes sense. Recursion is always such a weird thing for me. I wouldn't say that in an actual interview. That wouldn't be a great indicator. But it is the truth, so I'm being honest in this video. Maximum depth plus equals 1, because we know it's like maybe I need this. And maybe that works. So if root is not none, then we increase maximum depth by 1. If root dot left is not none, then we go into max depth, root dot left. So let's actually trace this kind of code. Okay. And then I'll think about test cases. Why not? I'll think about test cases. So we're at 9. Okay. We're at the root. Maximum depth is equal to 0. Maximum depth. Okay. I'll just get a pen since it's 0 right now. If root is not none, increase it to 1. Yep, it would be increased to 1 because it checks that we have a 9. So 1. And then if root is if root dot left is not none, maximum depth is equal to max depth dot root dot left. So we go in to root dot left. So 10 now. So 10 is here, and again, maximum depth is equal to 0. If root is not none, maximum depth plus equal 1. Okay. And so, oh jeez. Uh-oh. Yeah, cool. Okay. So yeah, it's 1. And that 1 that we know root dot left is not none, so that's not going to be true, it's going to be false. So this is skipped. And root dot right is not none, that's again false because it has no right subtree. So this is skipped as well, and then it just returns it. So now 1 is returned over here, and plus equals 1. Maximum depth. Oh, I see. It's not actually carrying the maximum depth, is it? Oh, that for the right side here. Root dot right. Let's go down here. 1 goes one more, goes one more. So 1 plus 1, 2, 2 plus 1, 3. It's actually 2 plus 3, which is 5. So it's not actually gonna work out. Hold on, so I'm going down these different paths. Okay, so this is fine. It's here that becomes the problem. Yeah, how would I do this? How would I, so I have 2 sides. So you got that here. And we do a no here, 1. We come here, we make a note, 1. This is the maximum depth, by the way. I'm just making a note to visit the node. Okay. And then we make a note down here. 1. 1. Oh, well, actually, let me get rid of that. Let's just loss of tree first. So it comes here. 1. Skips this, returns. Gets rid of this. Plus equals 2. Okay. Now here, for the right subtree, it goes down. 1 goes back up. And so the plus. 3, which is definitely not right, because when it comes back up here, it's going to do 1 plus 3, which is 4. That's not the right answer. So what I'm noticing is that this condition here, we want the maximum of both of these. Okay. Left up. Right up. Okay. And then we want the max. Maximum depth plus equals the max of left depth or right depth. And I think that should do the trick. So my example here was actually not that great because it didn't really consider this edge case of sorts. And I don't know if there's like, again, I gotta search up the definition of binary tree, but I don't know if you can have just like one node or something. So now let's go through it again. Oh, whoops. All right, so 1, 1. Okay, so this is the left root. 1, it goes down here. 1 jumps up. It doesn't make a decision yet. It has to still go to the bottom here, but it sees it as left depth, and it makes a decision here of 1. They're both the same, so it's just gonna add up. You know, you could choose really any of them, but it's gonna add up to 2. Okay. Now here, we definitely know that 2 is the bigger number. We take the maximum, so we take up 2. Just ignore this. So then 1 plus 2, no, that's 3. So this should work. I've confirmed it. I guess some test cases to test. We had like a full tree. We have where like 1. You know, let me type it out. Full, like complete tree. Both, you know, equal number of left and right subtrees. We have no tree at all, right? Like none. Root is none. That's an edge case, and what would happen when we do that? So skip through all of this. Okay, that's a problem. That's a problem. Because left depth and right depth, so that's going to give us a syntax error right here. Like this, and like this. Zeros. So if it comes here, it's 0, and it returns 0. For root is none. Perfect. Great test case. Only root and left subtree, only root and right subtree. And really, that's the main test cases. Other than that, yeah, even full and complete, it's just like all that means is a tree, with oh my god, a tree with a root. I'll say a root with the left and right subtree. Yeah, those are the conditions. In terms of writing it out, again, I don't think I'll have unit tests for my own interview, I think. So I'll leave it at that. Yep, that should be good. Rip. What did I do wrong? Did I spell it wrong? Maximum. I did. Did I spell it wrong? I don't know where max depth is not defined. It is defined right there. Or do I have to do solution dot max depth? Wait, what's the issue here? Hold on, let me pull this up. Max depth is not defined, but it is defined right there. Max depth. Could you not call a method on itself? Or okay, well let's bring back solution not max depth. Right. So is that the problem? But then it didn't give me a problem here. What's going on? Oh, this looks weird. That wasn't recursion that I remember. So maximum that, right that. Okay, beautiful, 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 beautiful. No! Oh, am I doing it wrong? No, I'm not. Oh. Oh. Elf. Elf. Because it runs all the statements despite whether or not this is a none. Good point. Good point. Oh, that's a problem. That is a problem. Okay, simple solution. Want to see what it is? You see my genius? Oh, man, I'm tired, man. Oh. So that is O of n time complexity. Beats 13%. What unique solution are people doing? If not root returns 0, LH self dot max depth. Oh, am I supposed to do self dot max depth? Oh, okay. Good to know, good to know. Root dot left, RH that 1 plus max LH RH. Okay. I'm still all of n time complexity though. Yeah. So you're going through all the nodes. That's all. Yeah, test cases. Example. Test cases. Just copy paste that from here. Whoa. There we go. And submit that one more time. Alright, cool. And I'll just, yeah, I'll leave it at that. Okay, thank you.